Hello, I am Sujit. Welcome to Physics 2020. So, let me continue my discussion in the topic of relative velocity in two dimension. So, in relative velocity of two dimension, we have two topics, that is the Riemann problem and the riverboat problem. So, we are discussing the sums of Riemann problem. So far we have discussed 8 problems. So, three more problems we have to discuss in this session. And after that we will go to the next topic, that is the Riemann problem or riverboat problem. So another very important information from Physics 2020. So my dear students, I am posting some other videos in this channel, that is solutions to hcverma. So my dear students, those who are preparing for JEE exam, you all know that is hcverma's book is very important, that is concepts of physics, hcverma's concepts of physics. So in that book the problems are discussing by Mr. Anup Kumar. He is from Visakhapatnam, Andhra Pradesh. He is my brother-in-law also. He is discussing the solutions and the concepts of, that is hcverma problems. Okay, so he is a very great man, very expert in physics, a lot of years experience in physics. So you go and watch it, that is you can feel the difference. Okay, so very good teaching. The importance of his teaching is anybody can follow his teaching, whether it is below average, average, or an intellectual student can also follow his teaching. So very beautiful manner he is explaining the concepts and the problems, not only the problems, so the concepts related to the problems also he is discussing. Go and watch it. Okay, so we will go to the next problem, that is 9th problem. A man is going in a topless car with a velocity of 10.8 km per hour. It is raining vertically downwards. He has to hold the umbrella at an angle of 53 degrees to the vertical to protect himself from rain. The actual speed of the rain is. So the four options are given: 2.25 meter per second, B 2.8 meter per second, C 5 meter per second, and D 2.7 meter per second. So understand the situation. Consider this is a car. Okay, car. He is traveling in a car. Okay. So it is raining vertically downwards. So the car is moving with the velocity. What is the velocity? That is 10.8 kilometer per hour. Kilometer per hour. So it is given, it is raining vertically downwards. But he has to hold the umbrella at an angle of 53 to the vertical. That means, what is the meaning? A man in the ground feels that rain is falling vertically downwards. But the man in the car feels that the rain is coming at an angle of 53 to the vertical. So that's why, so if the rain is coming vertically downwards, means he has to hold the umbrella. He has to hold the umbrella like this. But it is given, that is he has to hold the umbrella 53 degree to the vertical. Okay, 53 degree to the vertical. This angle is 53 degree. That means the rain comes at an angle of 53 degree to the vertical to protect himself from the rain. The actual speed of the rain is. So the actual speed of the rain is, means the velocity of the rain velocity of the rain or speed of the rain with respect to the ground we have to find. Okay. So this is the situation. So what is the speed of the rain with respect to the ground? Speed of the rain with respect to the ground is equal to, what is the formula? So if you are taking, that is vector, velocity of the rain with respect to the car plus velocity of the car with respect to the ground. So this is the formula. Am I right? Velocity of the rain with respect to the ground is equal to velocity of the rain with respect to the car plus velocity of the car with respect to the ground. So velocity of the rain with respect to the ground is the resultant of two vectors. Velocity of the rain with respect to the car plus velocity of the car with respect to the ground. So the rain is coming, velocity of the rain with respect to the car, that is, so this is the vertical. Okay, so the rain is coming at an angle of 53 degree. 53 degree. What is this? This is the velocity of the rain with respect to the car. Okay, so next, velocity of the car with respect to the ground. So it is in this direction. Velocity of the car with respect to the ground. So one vector. What about this angle? This angle is 53 degree. 53 degree. Okay, 50 degree. So one vector is in this direction. So the resultant is in this direction. This direction. What about this vector? This vector is velocity of the rain with respect to the ground. Okay, ground. So VCG is given, that is 10.8. 10.8 it is given. So from this diagram I am finding that is tan 53 degree. Okay, tan 53 degree is equal to opposite side VCG divided by adjacent side, that is VRG. VRG. Am I right? VRG. So 53 degree is a famous triangle. So this angle is 53 degree. 53 degree. So what are the sides? 4, 3, 5. Okay, 4, 3, 5. So tan 53. So opposite side, that is 4 by adjacent side, that is 4 by 3 is equal to VCG, that is 10.8 divided by VRG. VRG. Okay, VRG. Clear? So from this VRG is equal to 3 into 10 to the power 10.8 divided by 4. So cancel it 2 times 2, 5 times 4. Okay, again cancel 2. 2 times 7 times. Okay. So VRG is equal to VRG. What is VRG? Velocity of the rain with respect to the ground. Okay, VRG is equal to 3 into 2.7. Okay, 3 into 2.7. So 8.1. Okay, so 8.1 VRG is equal to, that's equal to 8 8.1 kilometer per hour. Kilometer per hour. But the answer is given in meter per second. Okay, meter per second. So how to convert meter per second? 8.1 into 5 by 18. Okay, 5 by 18. So 2 times 0.9. Okay, 0.9. 0.9 into 5, that is 4.5. 4.5 divided by 2. So 4.5 divided by 2 is equal to, that is 2.25. Okay, 2.25. So what is the answer? Option A is the answer. 2.25 meter per second. So that's equal to 2.25 meter per second. Clear? So this is the answer. So 10th question. A stationary man observes that the rain is falling vertically downward. When he starts running with a velocity of 12 km per hour, observes that the rain is falling at an angle of 60 degree with the vertical. The velocity of the rain with respect to the running man is. So initially the man is at rest. So he feels that the rain is coming, rain is falling vertically downwards. So he started to run. Okay, he starts running with a velocity of 12 km per hour. So at that time, when he is running with a velocity of 12 km per hour, he finds that the rain is coming at an angle of 60 degree to the vertical. Okay, to the vertical. So the velocity of the rain with respect to the running man. So we have to find the velocity of the rain with respect to the running man is. So velocity of the rain with respect to the man we have to find. Okay, is equal to velocity of the rain with respect to the ground plus velocity of the man with respect to the ground. It's the formula. Velocity of the rain with respect to the running man. Okay, running man is equal to velocity of the rain with respect to the ground plus velocity of the running man with respect to the ground. Okay. Velocity of the rain with respect to the ground. It is falling vertically downwards. Okay, vertically downwards. So stationary man observes that the rain is falling vertically downwards. This is velocity of the rain with respect to the ground. So here that is velocity of the minus. Okay, velocity of the man with respect to the ground. So minus means in this direction. Velocity of the man with respect to the ground. So he is running. This value is given, that is 12 km per hour. Okay, 12 km per hour. So what is the resultant? Resultant is this one. Okay, what is the resultant? That is velocity of the rain with respect to the man. So it makes an angle, it is given in the question, that is 60 degree. Okay, 60 degree with the vertical. So okay, Kadam. Tan, from this diagram, tan 60 is equal to opposite side, that is V mg divided by V rg. Tan 60, that is root 3, is equal to V mg, okay, that is 12 divided by V rg. Okay, V rg. So V rg, from this V rg is equal to 12, we can write, that is 4 into 3 divided by root 3. Okay, so root 3 we can write the root 3 into root 3. So this root 3, one root 3 is cancelled. Okay, root 3. So remaining is, that is root 3. Okay, root 3. So from this VRG is equal to, from this what we can find, that is VRG is equal to, that is 4 root 3. Okay, 4 root 3. So this value you are finding, that is equal to 4 root 3. Okay, VRG is equal to 4 root. What we have to find? The velocity of the rain with respect to the running man. VRM we have to find. Okay, VRM. So VRM is equal to VRM, velocity of the rain with respect to the running man. Okay, so it is a right hand triangle. Okay, VRM is equal to square root of. So 12 square plus 4 root 3 the whole square. So that's equal to 12 square 144 plus 4, that is 16. 16 into 3, that is 48. Okay, 48. So that's equal to 144 plus 48. Okay, 48. So 16 we can take commonly outside. 16 root of 16 into 9 plus 16 into 4, that is 16 into 9, that is 144. 9 plus 3. Okay, 3. So 16, that is equal to 4 root of 9 plus 3, that is 12. Okay, 12. Again we can write that is 4 into 3. Okay, 4 into 3. So that's equal to 4 into 3. So that's equal to 4 square root of 4, that is 2. 4 into 2, that is 8. So 8 root 3 is the answer. 8 root 3 is the answer. Clear? So 11th question. Rain is falling vertically with a speed of 35 meter per second. Wind starts blowing after some time with a speed of 12 meter per second in east to west direction. In which direction should a boy waiting at a bus stop hold his umbrella? So a boy is standing at the bus stop. Okay. So the rain is falling vertically with a speed of 35 meter per second. So the boy has to hold the umbrella like this. Okay. So in order to save himself from the rain. Okay. Now the wind starts blowing after some time with a speed of 12 meter per second from east to west direction. Okay, west direction. So in which direction should a boy waiting at a bus stop hold his umbrella? We have to find. So anyway, that is velocity of the rain with respect to the boy we have to find. So that's equal to velocity of the rain with respect to the ground minus velocity of the boy with respect to the ground. So that's equal to velocity of the rain with respect to the ground minus velocity of the boy with respect to the ground. That is, the boy is at a stationary. Okay, stationary, that's 0. So that's equal to velocity of the rain with respect to the ground. Okay, ground. Now the wind starts flowing. Okay, starts flowing. So we can draw the vector diagram, that is velocity of the rain with respect to the ground. So that's equal to 35. Okay, 35. So without wind means, so this is the direction of the velocity of the rain with respect to velocity of the rain as seen by the boy. So without wind, this is the, now the wind starts flowing from east to west direction. Okay, east to direction with the direction. So this is velocity of the wind with respect to the ground. So that's equal to, that is 12 meter per second. 12 meter per second. So what is the resultant of the rain? So the rain must be in this direction, So making an angle theta with the vertical. So the rain is coming in this direction means, so he has to hold the umbrella, in this direction. Okay. So what about theta? Tan theta is equal to V WG divided by V RG. So that's equal to 12 divided by 35. Okay, 12 divided by 35. So theta is equal to tan inverse of 12 divided by 35. Okay, 12 divided by 35. So the value is, so that's equal to, theta is equal to 18.92 degree. Okay, so theta is equal to 18.92 degree. So it is vertical. So theta 18 degree 90 degree means, so what is the answer? The umbrella should be in the direction of, that is 18.92 degree. Okay, degree with the vertical towards east. This direction is east direction. Okay, east direction. So this direction, that is north, south, east, west. Okay. So the umbrella, the boy should hold the umbrella in a direction 18.92 degree, 92 degree towards east, That is the answer. Okay, answer. Clear? So with this we wind up this session, that is Riemann problem. So totally 11 problems we have solved in this section. Okay, so very important topic, that is relative velocity in 2 dimension. So our next topic is, that is Riverman problem or Board River problem. Goodbye.